Okay, I hope you enjoyed the video of the levitating frog. I always do. Um, so what I'm going to do is I'm going to take a well-fed spherical frog of the length 8 centimeters, so that means its diameter is 8 centimeters as well. And, oh, that's weighs. That should have an S. Um, and he's got a diamagnetic susceptibility of water. Something I'm going to have to look up. I want to figure out what his magnetic moment is. Okay. And so, how did we look at this previously? We said the moment in a field, so what's happening here is they're putting a magnetic field this way, B, and that's creating a force this way, F, that's, or a moment this way, that's levitating the frog. Okay, so that's equal to chi over the susceptibility, which is the thing we have to look up, over this mu naught that we were just talking about, the permeability of free space, which is actually something you worry about mostly in SI units, times the volume times the magnetization. So let's see. We need to figure out what the volume of the frog is, and we need to figure out what the diamagnetic susceptibility of water is. So let's see, chi is minus 9 times 10 to the minus 6. Okay, so that seems pretty straightforward. That's all we need for that guy. And the volume is, well, I said he's a spherical frog, so that's 4 pi over 3 times r cubed. Okay, so r is what? 1/2 of 8 centimeters, so that's 0.04 centimeters cubed. All right, so that's 4 pi over 3. 4 times 4 is 16. 16 times 4 is 64. For each one of those centimeters, and there are 3 factors of centimeters, I get a 10 to the minus 2, so that's times 10 to the minus 6 meters cubed. Okay, then we have to use the calculator because 4 pi over 3 is a weird number. Let's see, 4 pi times 64 divided by 3 is 268 times 10 to the minus 6 meters cubed. So this number we're going to bring back over here. Oops. That's the magnetic field, B. I'm sorry. Okay, so I just said, let's see, chi was minus 9 times 10 to the minus 6. And we have permeability of free space is 1.256 times 10 to the minus 6 Teslas per amps per meter. Let's see, what else do we have? Then we have the volume, which is 268 times 10 to the minus 6 meters cubed. Okay. And we have the magnetic field. Did I mention the magnetic field? Oh, I did. Okay, here it is. It's 5 Tesla. So it's a 5 Tesla magnetic field. Okay, then we have lots and lots of multiplying to do. We've got lots of these 10 to the minus 6s, so we can cancel out a couple of them, right? And then we have 9 times 5, which is 45, divided by 1.25, which is 5 over 4. Actually, I could do that in my head if I wanted to. I'm just going to use the calculator again. We're going to come up with minus 9.65 times 10 to the minus 3 amps meters cubed. So that's minus 9.65 milliamps meters squared. I'm sorry. So this is a meter cubed. This goes up here. That's an amp per meter. Right? Teslas cancel. So we have meters squared. Amps times meters squared. Okay, so there we go. That is that example. Got three things. We have to look this guy up. We know this guy. Then the magnetic field is fortunately given, but we need to find the volume. So that's sort of the complicated part here. After we do that, we plug the volume back in with all these other values that we already had, and we end up with this. It probably should be minus because it's diamagnetic, so it's supposed to be in the opposite direction. All right, so there we are. That is how you levitate a frog. And if that isn't enough fun for you, I don't know what is. All right, I'll talk to you later. Bye now.